Assalamualaikum and welcome back to another video on my channel. So in this video, as promised, we would be covering the scalar and vector quantities and along with that how to find the resultant of two vectors. So without any further ado, let's start off. So basically what are scalar quantities? What are scalar quantities? Scalar quantities are all those quantities that only have a magnitude and no direction. So basically scalar quantities are all those quantities. Scalar quantities are all those quantities which have only the magnitude and no direction. And no direction. So basically, these are the scalar quantities. And by magnitude I mean magnitude means value. Any value, any random number, one, two, three, four, five, six, any random number. What are some examples for scalar quantities? Examples for scalar quantities. So basically, some examples for scalar quantities are distance, speed, time, mass, volume, and density. These are the six examples for scalar quantities. And all of these only have a magnitude, no direction. Speed doesn't have a direction. Same with distance, mass, time, volume, density. They don't have any direction. They just have a value of one, two, three, four, any random number. Moving on to the vector quantities. Now, what are vector quantities? Vector quantities are all those quantities which have a magnitude and along with that a direction as well. Basically, vector quantities are all those quantities which have a magnitude, and along with that, a direction as well. A direction as well. This is what is meant by the vector quantities. Again, I'm repeating. Magnitude means value, any random number. What are some examples for this vector quantities? Examples: um, force, acceleration, acceleration, um, displacement, displacement, and velocity. These are the examples for vector quantities: force, acceleration, displacement, and velocity. One thing I would like to clarify over here is that distance and displacement are two different things. What do I mean by distance? Basically, distance is the actual path covered, or the total distance traveled is known as a distance. And displacement is the shortest distance covered between two points, or another definition for it is change in position of an object is called displacement. So both of these are different things. And in detail, we would cover distance and displacement in our next chapter, which is kinematics. So this was all for scalar and vector quantities. Now, how would we find the resultant for two vectors? But before that, there are some things that we would go over. What do I mean by resultant force? Resultant force. It is it is the sum of all the forces acting on an object, acting on an object. It is also known as net force. Net force. So what is resultant force? It is the sum of all the forces acting on an object, and it is also known as net force. And the symbol for displacement is, one thing more. The symbol for displacement is D, capital D. No, actually small d, and the the unit for distance is symbol for distance is S. Distance is written as S, and displacement is written as D. Moving on. Now, resultant force is the sum of all the forces acting on an object and is also known as net force. One thing we need to keep in mind while calculating the resultant of vectors is that scalars can be added, but while adding or subtracting vectors, we need to keep in mind the direction of the arrows as well. So basically, scalar quantities can be added, but while adding vectors, we need to keep in mind we need to keep in mind the direction of the direction of the vectors. This is something you need to be very careful of while adding vectors. When do we add vectors and when do we subtract vectors? So basically, um, when do we add vectors and when do we subtract? This is when, and the other this is when we add vectors. This is when we add vectors. And when do we subtract vectors? It's when it's this way. Okay, this is when we subtract vectors. Subtract. So basically, this is when we add and this is when we subtract. And one thing more that you need to keep in mind is that whenever we are, whenever we are, whenever two vectors are of 90 degrees, they will be known as perpendicular, and we would use Pythagoras theorem to find it out. Obviously, you know what is Pythagoras theorem. It's hypotenuse square is equals to perpendicular square plus base square. So if, like for example, if um, um, for example, this and then this, now the angle between these two is 90 degrees. 90 degrees, right? Now, if the angle between two vectors is 90 degrees, so to find its resultant, what you would simply do is apply the formula for Pythagoras theorem, which is a square, a square, a to the a square is equals to b square plus c square, b square plus c square. This is the formula for Pythagoras theorem. Now, what if the angle isn't of 90 degrees? Then what would you do? Then what you would simply do is that this is what you are going to do. If you want to add it that way, then you have to use the head to tail rule. Now, what is the head to tail rule? Okay, so basically, head to tail rule. It's the graphical method, okay? Head to tail rule. Now, what is head to tail rule? Head to tail rule. Okay, so basically, what is head to tail rule? Head to tail rule is this. I'll tell you what is head to tail. This is the head to tail rule. This is the head to tail rule. Now, um, in head to tail rule, what you simply do is that from the like from the end of the first vector, you start your second vector. For example, this is the end of this vector, and what you simply do is you start your second vector from here. This is what you do in finding the resultant for two vectors which aren't of 90 degrees. And for 90 degrees as well, you do it the same way, but you apply this formula. A squared is equals to b squared plus c squared. Um, plus c squared. So over here now, what is your next step? For example, take this as 3 newtons, 3 newtons, and take this side as 2 newton, 2 newton. Now what would you do? To find the resultant for this, what you would simply do is that you would connect a line from the tail of the first vector to the head of the second vector. Okay, this is very simple. This is the head. Okay, and what you would do is that just calculate, draw a line, draw a line from here. For example, if this is of 7 newtons, 7 newtons, this is your result. It's as simple as that. Nothing more. It's simple. In detail, we could cover this thing again in our next video as well. This is it for this video, and I will see you all tomorrow, inshallah. Till next time, Allah Hafiz. Please do like and subscribe my channel. Allah Hafiz.